Okay, so let's do some examples. We want to find the domain. And the first example is going to be y is equal to the square root of 2x plus 1. Remember, if it's going to be a restricted domain, it's going to fall under one of these three options. If it's not one of these three options, your domain will be all real numbers. All right, so the first one is if we have a fraction with a variable in the denominator, is there a fraction here? No. The second restriction, you just have a radical with a variable underneath the radical. Does that fit the bill here? Do we just have a radical with a variable underneath the radical? Okay, so we're going with the second one. What is the restricted domain for the second one? Our restricted domain is our variable expression. Whatever is underneath that radical is going to have to be greater than or equal to 0. So what do? We take whatever's underneath that radical, 2x plus 1, and it will be greater than or equal to 0. Obviously, we don't stop here. We're going to have to solve for x since the domain represents all the x's. We got to get it just down to x. So I'm going to subtract 1 on both sides, and we have 2x is greater than or equal to -1. Then we will divide by 2. This got a lot of you on the Desmos. Remember Algebra 1? What happens when you divide by a negative? The sign flips. Don't forget that. Don't forget your basic algebra rules. So our domain will be, I'm going to put D, our domain will be x is greater than or equal to -1/2. Now, if I wanted to write this in interval notation, I think did we speak about both interval and set notation? All right, if I wanted to talk about this in interval notation, this is saying x is greater than or equal to -1/2. So I'm going to do with the square brackets since -1/2 is included. And we go -1/2, comma, and it's going all the way to infinity. We can never reach infinity, so that's going to be a parenthesis. All right, next one. Okay, remember, your domain is all real numbers unless it falls into one of those three scenarios. So we go back up. We just have y equals 2x plus 1. It's not a fraction, so there's no variable in the denominator. This one's out, right? There's no radical. Since there's no radical, we don't care where the variable is. And the last one is a radical in the denominator, but it's not a fraction. So does it fall under any one of these three? No. So what is our domain? All real numbers. There's no restriction here. So you're allowed to do the double R for all real numbers. Or if we're writing interval notation, it's the infinities. So it's -infinity to +infinity. Okay, I want you to try these next two on your own. Oh, sorry, I'm changing this one. There we go. Okay, let's look at this. Is there a restriction on number 3? Absolutely. So we have to see which restriction does it fall under. We have 3. 1 of 3. So is there just a variable in the denominator? Is there a variable underneath a radical? Is there a variable underneath a radical that's in the denominator? So 1, 2, or 3. Which scenario is this? 1. So when there's just a variable in the denominator without a radical, we have to set that whole denominator expression and say this cannot equal 0. So that's what we're going to do. We're going to take x minus 2 and say this cannot equal 0. In what scenario will x minus 2 equal 0? When x is equal to 2. So x cannot equal positive 2. You would just solve whatever that equation is. So I just added 2 on both sides. So this is our restriction. X cannot equal 2. That means it could be any other number under the sun except 2. Could it be 2.1? Yes. Can it be 2.0075? Yes. It could be any number, just not 2. All right, number 4. Again, there is another restriction here. So which one does this fall under? 1, 2, or 3? Chels? 3, you got it. So in 3, because we have a variable in a radical in the denominator, we have to say that whole variable expression that's in the radical has to be greater than 0. So we're going to go through this, and we're going to say x plus 3 will be greater than 0. And we solve it. So we subtract 3 on both sides, and we will get x is greater than negative 3. If we wanted to write this in interval notation, it's going to be parentheses negative 3 to infinity. Okay, so now we are going to, actually, one more. Yes, Callie?
What you just did, why wouldn't the interval notation be the bracket of negative 3?
Oh, good question. Because if it were negative 3, if it were going to be in the bracket instead of the parentheses, we'd need the line underneath the inequality sign. It'd have to be greater than or equal to, but this is just greater than because it's not allowed to be 0. All right, you all tell me what's number 5. All real numbers. There's no restriction at all here. So this is an R. If we're doing interval notation, it's negative infinity to positive infinity. All right, now we're going to step it up. My question to you, is there a restriction and why or why not? Yes. Mia, right?
Yeah.
Okay, why?
There's a number on top and an x on top.
Good. Because there's an x in the denominator, there's going to be a restriction. Because there's no radical, right? There's no radical anywhere. It's not going to be restriction 2 or restriction 3. That leaves us with just restriction 1. So we're saying the whole variable expression, x squared minus x minus 6, cannot equal 0.
X can equal 3 or negative 2.
Good. What did you do to find that?
You have to split it up like x minus.
Good. You have to factor. How did we know we had to factor this? Does anybody know? By looking at this, how did you know it was a factoring problem?
Because it starts with x
You got it. Whenever you have an x squared, more likely than not, it's going to be a factoring problem. When I say factoring, that's the double set of parentheses. That's what I mean when I say factoring. So we have, when we're factoring, we're going to think of two numbers that multiply to the last number, but add to the middle coefficient. Even though there's no number written in the middle, do we all know that's a 1? So we want two numbers that add to a -6, that multiply to a -6, but add to a +1. Could anybody else think of two numbers that multiply to a -6, but add to a +1? Aaron?
-3, 2.
Yep, -3 and a +2. Then you check the addition. Does -3 plus a +2 add to -1? Yes. So when you go to factor, you set up your double set of parentheses. You're going to put an x in the front of each parenthesis. And then we put in the numbers that we guessed, x minus 3, x plus 2. But now what we want to do is we want to see what makes these 0. So we have x minus 3. We know we do not want it to equal 0, and we want x plus 2. We want it to not equal 0. So we go ahead and solve this. We know x cannot equal +3, and x cannot equal -2. This is our restricted domain. So basically it's saying our domain could be any number except 3 and -2. Do you want to see how you would write this in interval notation? All right. So for me, I would always just choose to write it like this. I wouldn't opt for interval in this one because this is just a lot easier. But if you did want to write it in interval notation, the way it would be written is you would say, okay, I'm going to go from -infinity all the way to my smallest number, which is -2. And we're going to stop. Then what we're going to do, we're going to go from -2, it's not included, right, all the way to 3. Also 3 is not included, but all the numbers in between are. Then we're going to go from 3 to +infinity. A lot easier just to say x can't equal 3, x can't equal -2, right? Okay, next one. I'm going to put a star on this next one because it's the most complicated type of problem that we're going to be doing. We definitely know this is restricted. We know it's restricted because we have a radical and we have a variable underneath the radical. So in this restriction, what do we say to do? We say take the variable expression. So we're going to take the variable expression. And is it going to be greater than 0 or greater than or equal to 0? Which one is it? Is it this one or this one? Choice A or choice B? Which one?
B.
Ethan? B, good. So we're going to go with choice B because it's allowed to be 0 because we're not in the denominator. So it's allowed to be 0 because it's not in the denominator. So we know this one is out. So I'm going to go with x squared minus 4 is greater than or equal to 0. Anytime you have a quadratic inequality, I'm going to write this out. Anytime we have a quadratic inequality, we must test the regions. And it's a pain. So what do I mean when I say a quadratic inequality? I mean when I have something squared, a variable squared, meaning I'm going to have to factor, and the crocodile mouth. That's essentially what a quadratic inequality means. Something that needs to be factored paired not with an equal sign with the crocodile mouth, that's an inequality. We're going to have to do something called test the regions, which is a pain to do. So step 1, factor. So this is a dot. It's a difference of 2 squares. So when we go to factor this, it's going to be x plus 2, x minus 2 is greater than or equal to 0. Does anybody need to explain how I factored that? Okay, great. Then what you want to do is you are going to solve for x, but those are just going to be your testing numbers. So I'm going to solve for x and use as reference numbers. So what do I mean by that? When I solve for x, do you guys all agree I would get a -2 here and a +2 here? All right, those are not our answers. Those are going to be our reference numbers, and now we will have to test the regions. Step number 3, test the regions. So the way we test the regions is we make a number line, and we go back to our reference numbers, and I pick the smallest net reference number. Which one is the smaller reference number, -2 or +2? -2, right? -2 is the smaller reference number. And what we're going to do is we're going to test x is less than or equal to, you use whatever inequality we have here. Because it's equal to, we're going to use equal to. If it was just greater than, we just do less than. So it's whatever corresponds to what we have. So x will be less than or equal to our smallest reference number, which is -2. And then we'll test the region between the two reference numbers. So -2 is less than or equal to x, which is less than or equal to 2. And then our final region that we're going to test is greater than our biggest reference number. X is greater than or equal to +2. I know it's a pain, but trust me, you'll get the hang of it. We'll do enough where it's not so bad. And you probably did this in Algebra 2, you just forgot. Okay, so what are we going to do? We want right now, do you see how this inequality sign is greater than 0? If you're greater than 0, do we agree those are all positive numbers? Less than 0 is all negative numbers? Okay, so if we're greater than 0, we want all positive numbers. So I'm going to go ahead and I'm going to take a number that's less than -2. Never use the reference numbers. I'm going to choose a number that's less than -2, which is -3. And I'm going to test this. -3 plus 2, and then -3 minus 2. All we care about are the signs. So -3 plus 2, do we agree that's a negative number? And then -3 minus 2, isn't that another negative number? So then what is a negative times a negative? Positive or negative? Positive. Because it was greater than 0, we wanted a positive outcome. Isn't this a positive outcome? Okay, so that means this is part of my winning domain. This is a winner. Now let's check. We're going to test between -2 and +2. What's the best number between -2 and +2 to use?
1.
Less than 1.
0.
0. If 0 is an option, 0 is always the best option. So now we're going to test 0. So we're going to say 0 plus 2 and 0 minus 2. All we care about are the signs. 0 plus 2, do we all agree that's a positive? 0 minus 2 is a negative. What's a positive times a negative?
Negative.
A negative. Did we want our outcome to be negative? No. So this loses. This is out. Now we test the last region. greater than 2. Let's go with 3. So I'm going to have 3 plus 2 and 3 minus 2. 3 plus 2 is positive. 3 minus 2 is also positive. Positive times a positive is a positive. Okay, a little hint for you. Generally speaking, if the first column works, the last column will work. And if the first column doesn't work, the last column won't work, and the middle column will work. So really all you have to do is test one region, and you'll know. If this one works, then these two are your answers. If this one doesn't work, then this one is your answer. So how do we write this? Our domain is going to be x such that x is less than or equal to -2, or x is greater than or equal to 2. I'm not going to insist you write it in the brackets. If you just wrote x is less than or equal to -2 or x is greater than or equal to 2, you're still good. The interval notation for this will be -infinity, comma, +2 square brackets, or square brackets 2 to +infinity. Ready to try another one? All right, you tell me, is there a restricted domain here?
No. Maybe.
Yes, there is a restricted domain. Why? Because we have a radical, right? A radical can't be negative. We can't be negative underneath the radical, so we can't have an imaginary number. So what is our restriction here for the domain? We're going to take the expression inside the radical, and we're going to say, is it greater than or equal to 0, or just greater than 0? Greater than or equal to 0. You got it. Because our number can be 0 in the radical. That's fine. This is the special scenario where we're going to have to test the regions. Well, how do I know this is a special scenario where I have to test the regions? Not only do we have to factor and what is there. Because if I just, no, not the square root. If I just had this, I wouldn't have to test the regions. But this first one, I would. Because it's an inequality. Anytime you have to factor with an inequality, you have to test the regions. So we're going to factor this. We are x minus 4, x plus 3 is greater than or equal to 0. Who remembers what we do next?
Make the chart.
Okay, make the number line.
Yeah, the number.
But how do we find the numbers for the number line?
You pick the smallest one.
But first we do what before we pick the smallest one? Forgot. Maddie?
You set them to 0.
Yeah, we set them equal to 0. So x minus 4 equals 0, we'll get positive 4. X plus 3 is equal to 0, we'll get negative 3. Now we pick the smallest number. What's the smallest number? Negative 3. So we're going to choose x is less than or equal to negative 3. That's one section. What's the next section? How are we going to label it?
Negative 3 greater than or equal to x. Or
Less than or equal to x.
less than or equal to 4.
You got it. And then we're going to have x is greater than or equal to positive 4. Okay, so now we test. So we want less than or equal to negative 3. I'm going to choose negative 4, and I'm going to plug in. Negative 4 minus 4. Do we all agree that's a negative?
Yeah.
Negative 4 plus 3, once again, a negative. A negative times a negative is a positive. Do I want my outcome to be positive or negative?
Positive.
Good. How do we know? Because our inequality was saying we're greater than 0. If we're greater than 0, then we're positive. That's how we know we want the outcome to be positive. So remember what I told you. If the first column works, what else will work? The last one. And what will not work?
Middle.
The middle. So now we have our answers. So now we're going to say x is less than or equal to negative 3, or x is greater than or equal to 4. That is our domain. Okay. I'm going to show you one more, then I'll have you do a couple on your own. In number 3, what have I already done?
Factor.
I've already factored. So this is nice. I've already factored. This is nice. So what are we going to do here? We're going to take our factored form and say it's greater than or equal to 0. Would I still need to test the regions on this?
Yeah.
Yeah, I would still need to test the regions on this. So we would get x equals negative 3, x equals positive 4. We just did this, didn't we?
Yeah.
Yeah, I should have picked a different problem, but that's okay. So we just did this. So what are we going to end up with? I'll show you one more time. X is less than or equal to negative 3. Negative 3 is less than or equal to x, which is less than or equal to 4. X is greater than or equal to 4. This will work, and this will work. So once again, our domain is x is less than or equal to negative 3, or x is greater than or equal to 4. Okay, I'm going to give you 3 problems to try on your own. We'll go over them, and then we will call it actually 2, 3, 4, 5 problems. So once again, we're finding the domain. You're trying these on your own? If you need help, raise your hand. I'll come help.
Yeah, perfect. I just thought, like, I forgot, like,
You did it perfect.
just didn't carry on. Not equal to. Kill that. And then these should just be x can't equal 2x. So this one is a restricted domain because we have a variable in the denominator. Once we have a variable in the denominator, we know the denominator is not less than 0 on the line. Got it. And then we have this. Let's look at this. Good. times in the numerator.
Guys, for that last one, 1/3 x squared, that x squared's in the numerator. That x squared's in the numerator. It's not in the denominator. So let's work backwards. This one, there's no restriction. There's no radical, and there's no variable in the denominator. So this is in all real numbers, the domain here. For number 4, there's a radical and a quadratic underneath that radical. So we know x squared minus 9 will have to be greater than or equal to 0. When you have a quadratic and an inequality sign, what do we have to do? Test the regions. Factor, then test the regions. You got it. So this is x minus 3, x plus 3 is greater than or equal to 0. Our reference numbers will be a positive 3 and a negative 3. When we go to test the regions, we will test x is less than or equal to negative 3. Negative 3 is less than or equal to x, which is less than or equal to 3. And x is greater than or equal to positive 3. Your winners will be this one and this one. The middle will cancel. So we will get x is less than or equal to negative 3 or x is greater than or equal to 3. That is our domain for that one. Keep working backwards. For this one, we have a variable in the denominator. So x minus 10 cannot equal 0. So x cannot equal 10. We have a radical and a variable in the denominator. So for this one, we know x plus 4 must be greater than 0. No equal to. We can't be 0 in the denominator. We have to be greater than 0. So then, take the radical away. X plus 4 is greater than 0, so x is greater than negative 4. That's our domain for this one. And this first one, x squared minus 6x plus 8 cannot equal 0. There's no inequality here. Because there's no inequality, there's no crocodile mouth, we are not testing the regions. We are just factoring and saying we can't equal 0. So what will make this 0? X cannot equal positive 4, x cannot equal positive 2. That is our domain here. Okay, we are done for today.